Yes, please. So carbon is needed. How many electrons? It requires 4 electrons to achieve the 8 electron inert gas structure. So that is what it is, a tetravalency. So this tetravalency will represent like this. This is the representation of carbon tetravalence. What is the representation of carbon? This is what? The symbol of carbon. Putting just 4 short lines on the symbol of carbon is the representation of tetravalent. Anybody having any doubt, you can ask me. Are you clear, everybody? Yes, please. All of you. Completed? So this is what? So carbon always forms what bonds? Everybody? Carbon always will form covalent bonds. Carbon is a, what is the valence of carbon? It is the tetravalent. Clear, everyone? So next, the most important property of carbon, that is what? Self-combination. So self-combination is the extremely important property. This book itself I am showing you, so you can write it. So that is what we are studying, versatile nature of carbon. This is the extremely important. Directly we'll jump into the main concepts only, because I don't want to waste in the theoretical part. You should study. So versatile nature of carbon, the extremely important point. Why, sir, carbon is having this much importance in our daily life? Because of the property is called it as a self combination, which we used to call it as catenation. So catenation is the extremely the special character of a carbon, which is not shown by any other existed element in the universe. Of course, some other elements will show, but not like carbon. So that is the property which we used to call it as. What is the name of the property, everybody? Catenation. So carbon is having the unique ability to form the bonds with other atoms of carbon, giving to a large molecules. That is what? One carbon atom, another carbon atom, another carbon atom. It will be forming millions of carbon atoms together. Straight line. It is a branched point. It is millions of carbon atoms can be together in the form of chains. That property will never be shown by any other kind of compounds, any other kind of elements. That is the property we used to call it as a catenation. Most important, no other existed element will show this property like carbon. But there is a several elements which will show this catenation, but maximum up to 7 to 8 atoms. Remember, as I said, basically the carbon will form covalent bonds, but the bonds formed by the carbon is extremely stronger, not like other covalent bonds. And as the carbon is having a, what is the valency? Carbon. What is the valence of carbon, everybody? Tetravalency. And I told you the covalent bonds are 3 types. Can you tell me what is the covalent bonds? 3 types. Covalent bonds 3 types. Everybody?
Double bond.
Yes. Single bond it will form. Double bond it will form. Triple bond it will form. So every 3 bonds will shown by the carbon. Carbon can form a single bond. Carbon can form double bond, and carbon can form triple bond also. So like single carbon can form a single bond, carbon can form a double bond, carbon can form a triple bond also. So no other element can show this property. That is the property. It will form millions of carbon atoms together, long, straight or branched chains. That is what, even the carbon, this is arranged in the form of rings also. Carbon. It will be arranged in the form of rings also. This is what we used to call it as a catenation property, which is also known it as a self-combination. What is that name it call it as, all of you? Self-combination. So no other existed elements will show this property like carbon. But there are few elements. For example, silicon, underline this. Silicon also form the compounds with hydrogen which have chains of up to 7 or 8 atoms. But these compounds are very, very reactive. The carbon and compound bond is very strong and they are stable. I already mentioned you or not this point. Please respond, everybody. Am I told you or not?
Yes, sir.
Basically, covalent bonds are weak bonds, but the bonds formed by the carbon, they are highly stable in nature, and the compounds are very, very strong bond formation, and they are existing in a stable in nature. They are unreactive, much reacting won't be takes place. That is why carbon is special compared to other elements. Do you understand, everyone? All of you? And they will, because of this stability, the bond is very strong and they are very stable in nature. They will give us the large number of compounds with many carbon atoms linked to each other. So this is the extremely important point. That is what catenation. So what is the main versatile? Why carbon is very special? Because it will form millions of compounds with every other element. Reason is, it is itself, it can form a single bond, double bond, triple bond. Millions of compounds we can form it. That property of formation of self-linking or self-combination is only call it as, what we used to call it, guys? Everybody?
Catenation.
Catenation. Now itself I am saying you, please remember, if carbon is having single bond, carbon is having single bond, this is the representation of single bond. Note it. Carbon is having single bond, they are called it as a saturated compounds. Note it. Next, if they are having double bond, if they are having a double bond or they are having a triple bond, if they are having a triple bond, they are called it as a unsaturated compounds. Note it, everybody. At least one double bond, at least one triple bond is there. Wherever you see, in between the carbon and the carbon, in between the carbon and its carbon, it is unsaturated compound. You will study what is saturated, what is unsaturated. Don't worry. Do you understand, everybody? So carbon atoms may be linked by what? Self-linking, single bond, or maybe double bond, or maybe triple bond between the carbon and another carbon atom. So single bond is forming. That is what we used to call it as a what compound, everybody? Single bond means saturated compounds. Double bonds means unsaturated compounds. They may be react with other elements also. They will react with hydrogen, they will react with oxygen, they will react with the nitrogen, they will react with the sulfur, they will react with the chlorine. Many other elements carbon will react. That is why why, sir, what is the special? What is the special? Why carbon can react with this many? Answer is, what is the answer? Anybody? Compounds of carbon having double or triple bond is having, we used to call it unsaturated. What is the reason why we used to say this many things? Because the carbon, this is the answer, you have to write it. What is the answer? The carbon, the formation of strong bonds by the carbon atom and themselves and with the other elements also makes the carbon compounds very, very stable. Carbon and carbon also very strong bond. Carbon and other atoms also very, very strong. You can see compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, many other elements, giving rise to the compounds with specific properties which depends on the elements other than carbon present in the molecule. So keep it in mind, carbon also very strong bond. Carbon with hydrogen, carbon with nitrogen. Understanding? Nitrogen means triple. Carbon with oxygen. These bonds also very strong. That is why the compounds are stable in nature. That is among themselves and with other elements also, it is forming very strong bond. That is why the carbon is a special always. Clear, everybody? Do you understand, Amma? All of you? So that is what? What is the valency of carbon? Second point. Already we studied. Carbon is a what valency? 4. 4 means what? 4 what we used to call it as a tetravalent. Tetravalent. So second property. First, of course, we already studied. First importance. What is the versatile nature of carbon? First one is catenation. Catenation also call it as a what? Everybody? We used to call it as a self-linking. Self-linking or self-combination. So what is the another element which will also show self-combination, but which is very reactive and it is not existed more than 7-8 atoms? What is that? Silicon. Underline that, and it's very, very important. Okay, so they cannot form long chains like a carbon, but they are also will show the catenation property. So if you take sulfur also 8 atoms, after that it cannot be. Phosphorus 4 atoms, after that it cannot be. So that is what you have to remember. Are you clear, everybody? Yes, please. All of you? Yes. And next one, remember, the bonds that carbon forms with among themselves and other elements also very, 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 very strong. Because of this, the compounds are extremely, exceptionally, they are stable in nature. Purema, everybody. Understand, Hari? Sir, why, sir? Basically, covalent compounds are what compounds? Everybody. Covalent bonds are what? Weak bonds are strong bonds are? Everybody. They are what bonds? Everyone. Covalent bonds are weak bonds. But why, sir, carbon alone, it is a very strong? The reason is here. What is the reason? Everybody, check it. Read it and underline it. What is the reason, guys? What is the reason? Because carbon is a what? Small in size. And the valence electrons are holded very strongly held by the nucleus. I already told you this point. Have you remember, everybody? So the nucleus, it will held very strongly, that is valence electrons. That is the reason the nucleus will hold the shared pair of electrons also very, very strongly. So that is what makes the carbon and its compounds very stronger. So from this point, you should understand one thing. The size of the atoms increases. Size of atoms increases. Then what will happen? They'll become more weak bonds or strong bonds are? Everybody? They'll become weak bonds. Noted that. Extremely important point. Basically, periodic classification of elements, we will study that. But for you, it is deleted. That's why you should learn from this chapter itself. What is that? What is the reason? The bonds formed by the elements having bigger atoms are much weaker. Note it. Either it is a metal or non-metal, doesn't matter. Understanding? So the size of the atoms increases, the weaker the bond it is. Note it, everybody. Understand? Everybody? Mitakshri? Harvignesh? Abhirami? Anything doubt you can ask. Are you clear, everybody? So the size of the atom increases, the bond formed by it is weak or strong? Everyone? It is weak in nature. Why carbon bonds is very strong? Everybody? What is the reason? Answer, please. What is the reason?
It is small.
Yes, the carbon is very small, due to which the outermost electrons are strongly held by the nucleus. The outermost electrons are strongly held by the nucleus. Same way, the shared pair of electrons also strongly held by the nucleus. Because of this reason, the carbon is forming the extremely stronger and stable compounds. That is why carbon is special. Do you understand? Imagine we are having today 118 elements. All the elements can combine differently. They have been formed maybe maximum 1 million compounds. And you remember, the carbon alone can form 5 times more than all the other elements can form. All the other elements you combine and you get a different compounds. Whatever the number you get, the carbon alone can form 5 times more than the total number of compounds formed by other elements. And you know one more thing, carbon, till today there is no fixed number of compounds. Maybe today, by this class time, maybe new compound is discovered or formed by some scientist. Tomorrow, maybe another. Day after tomorrow, another. After you may grow, you may be showing interest in chemistry. You may be enter, you may be discover new compound. You may be form the new compound, carbon. So every day the count of carbon compounds is keep on increasing because of one property. What is the property, everybody? Because of property of what? Catenation. Understanding? And tetravalency. Next, third property. That is what? Multiple bonding. Here itself it will explain. Multiple bonding. It can form what bonds, everybody? It can form single bond. It can form, everybody, it can form double bonds. It can form triple bond. That is called it as a multiple bond formation. No other no other element will show this property. That is what we used to call it as a versatile nature of carbon. Why carbon is very special? It can form catenation. It can form it is having a tetravalency, and it can be self, like we can say single bond formation, double bond formation, and triple bond formation also. It can form branched chains. It can form straight chains. It can form what, everybody? Rings also. As I said, I mentioned, so it can be arranged in the form of, that is what, branched chains or straight chains, or in the form of rings also. So that is the special. Why? The reason behind large number of organic compounds or carbon compounds. Again, I'm saying carbon compounds also we can call it as a what? Organic compounds. Why it can be formed these millions of compounds? Because of self-linking, catenation. Self-linking is extremely important. Next one, multiple bond formation. Next one, tetravalency. And the next one is isotopes. So it will form isotopes. Okay. So sorry, not isotopes, isomers. So that is one more thing. Because of formation of isomers, the carbon is very special. So what is isomers? You just remember this word. Then when we are studying the further concept, you will understand what do you mean by isomers. Do you understand, everybody, what I'm saying? All of you? Isomers means it is. Okay. So now if it is a single bond, we used to call it as a what? Saturated compounds. And if it is the double or triple bond, we used to call it as a what, everybody? Double or
Unsaturated.
we call it as a unsaturated compounds. Okay. So let it be till here. I'm saying you. Then from here, the real chapter will start. From here only, very important. I never touch the basic thing. Now I am saying you what you need to read. This is the examples of allotropes of carbon. I already taught you what do you mean by the allotropes. What do you mean by the allotropes? Same chemical formula, but different what? Same chemical formula, but different what, everybody? Different physical properties. Okay. So different physical properties. That is what we used to call as allotropes. I don't have much time to teach this. So you should, if the time permits, we will finish the chapter early. Then I will teach you this. But you all should learn that. So carbon is having 3 allotropes, pure form of carbon. One is diamond, another one is graphite, another one is fullerenes. One of the example of fullerene is C60. This is the example of fullerene. So they have given you everything clearly. How many carbons it will varies in the fullerenes and all. I will explain you this, but you remember, you have to read this and you have to read it. And what we studied today, already what we studied previous chapter, single bond formation. Have you checked it? We studied or not? Single bond formation, I taught you or not? Verify it. Covalent bonds are 3 types. Single bond formation, single bond, double bond, triple bond. Single bond, I already given you many elements. Am I right, Hari? Given or not?
Sir.
Yes. Single bond, double bond formation, triple bond formation. You need to go through this. Every word is very important in this chapter. Anything can turn up into question in the exam. Now, why can't carbon cannot form anions, and why can't it will form cations? Why carbon? Carbon will never form anions also. Carbon will never form cations also, because it has how many electrons, everybody? Yes, please. 4 electrons in its valence shell. So that because of smaller in size, electrons are holded tightly by the nucleus. So it is not possible by gaining or loss of electrons. Only it can be shared. So the reasons they have given you here, you can see it could gain 4 electrons forming C4 minus anion. It can, but it cannot be, because it is difficult for the nucleus with the 6 protons to hold 10 electrons. Do you understand, Hari? What is happening? Are you clear? Mitakshri? Why can't it will be? Why can't it will gain the 4 electrons? Why can't it will gain the 4 electrons? Number of protons are how many? Number of protons in a carbon. How many, guys? Yeah, number of protons are 6, but number of electrons become 10. So 6 protons cannot hold 10 electrons. So that is the reason it cannot be. Next, as it is very small in size, electrons are very holded very tightly. Why can't it will lose the 4 electrons to turn up into cation C4 plus? Because it will require very large amount of energy to remove the 4 electrons, leaving behind a carbon cation with the 6 protons, and its nucleus holding it just 2 electrons. Yet it is impossible hold 6 protons again 2 electrons. That is why we need extremely high energy to remove these 4 electrons. Because of that, no formation of cation, no formation of anion, no sharing, no gaining or no losing of electron. Only by what, everybody? Only by sharing of electrons, it will attains the inert gas electronic configuration. It will attaining the 8 electron noble gas configuration. 8 electron noble gas configuration, or we can say inert gas configuration, only by sharing. Are you clear, everyone? That is what you have to do it. So you no need to learn this one. Okay, we will study that, no problem. But today's, when you are free, you are traveling time or whatever it is, every point I have taught you, today's class, except this table, this orange color table. But this formation of single bond, double bond, and triple bond, I already taught you in the last chapter. You have to go through that and you should remember. So the bonds which are formed by sharing of electrons, we used to call it as a what, everybody? Covalent bonds. Covalent bonds are 3 types. What is that? Single bond, double bond, and triple bond. And properties of covalent bonds. Tomorrow I will ask you, what is the properties of covalent bonds? Tomorrow I will ask you. You all should learn. Clear? And basically covalent bonds are very weak. You can see they are very weak. And that is the reason they're having what? Low melting and boiling points. They're having low melting and boiling points. So you all remember that. And they are also poor conductors of electricity or good conductors of electricity. Everybody. They are generally covalent bonds are what? Covalent compounds are what? Poor conductors or good conductors? Covalent compounds.
Poor conductors.
Poor conductors. That is what I am saying you. Please revise a concept of properties of ionic compounds, general properties, and as well as covalent compounds by tomorrow. Everybody need to learn. I know you don't have any DRD today. Everybody get back to work and start reading now itself till 7 o'clock. You can minimum time for getting ready. Okay, nothing will happen. So that's all. With this, I'll stop and I'll continue tomorrow. I hope you all understand. Anybody having any doubt, you can ask me. Clear, guys? Everybody? Yes, please. Every point, Okay. Thank you, everybody. We'll meet.